My dear students, so in previous class, let us discuss about the application of reciprocity law. Now, let us consider a problem. Determine the odd primes P for which 3 be a quadratic residue or quadratic non-residue, 3 be a quadratic residue or quadratic non-residue. So how? In order to find out the odd primes P, determine odd primes P which is in such a way that 3 is quadratic residue or quadratic non-residue. So we have to find for what values of P. For quadratic residue means 3 by P equals 1. Quadratic non-residue means 3 by P equals minus 1. So we have to determine the values or for what values of P at which 3 by P is 1 and 3 by P is minus 1. So how? So by quadratic reciprocity law, we have 3 by P into P by 3, P by Q into P by Q, Q by P, that is equals minus 1 power P minus 1 by 2 into Q minus 1 power P minus 1 by 2 into Q minus 1 by 2. Instead of Q, here it is 3, so it is 3 minus 1 by 2. That means, so 3 by P into P by 3 equals minus 1 power 3 minus 1 by 2 means 1. So it is minus 1 power P minus 1 by 2. Okay. So that means 3 by P equals, that means 3 by P equals P by 3 into minus 1 power P minus 1 by 2. Okay. So to determine P by 3, so to find P by 3, so we have to determine this P by 3 and minus 1 power P minus 1 by 2. Now to determine P by 3, we have to find P mod 3. To determine P by 3, we have to find P mod 3. P mod 3 and to determine minus 1 power P minus 1 by 2, yes, we have to find P minus 1 by 2 mod 2. Agreed? P minus 1 by 2 mod 2. To determine P minus 1 by 2 mod 2, it is enough to determine P mod 4. Clear? Okay. So 3 by P is P by 3 into minus 1 power P minus 1 by 2. To determine P by 3, we have to find P mod 3. And to determine minus 1 power P minus 1 by 2, we have to determine P minus 1 by 2 mod 2. That is to determine P mod 4. So, come to this product. P by 3 into minus 1 power P minus 1 by 2. Therefore, the right side is, to determine the right side, we have to determine P mod 3 and 4 means 3 mod P mod 12. Okay. So, to determine P mod 12, what is P? P is an odd prime. So, we have to determine 1, 3, okay, 1, 3, 5, 7, sorry, 1, 3, 5, 7, 11 mod 12. To determine 1, 5, 7, 11 mod 12. Clear? To determine P by 3, we have to determine P mod 3. To determine minus 1 power P minus 1 by 2, we have to determine P minus 1 by 2 mod 2. That means P mod 4. So, to determine that product, P by 3 into minus 1 power P minus 1 by 2, we have to determine P mod 12 since P be an odd prime. Hence, we have to determine 1, 5, 7, 11 mod 12. Why? Because 1, 5, 7, 11 are relatively prime to this 12. Clear? Why 3 is excluded there? Since 3 and 12 are not relatively primes. Clear? Okay. So 1, 5, 7, 11 mod 12. Now first we consider first case P congruence to 1 mod 12. P congruence to 1 mod 12. P congruence to 1 mod 12 means it is P congruence to 1 mod 3 into 4. So P congruence to 1 mod 3 and determine P congruence to 1 mod 4. Okay. Consider P congruence to 1 mod 3. P congruence to 1 mod 3. It's of the form M congruence to N mod P. M congruence to N mod P means M by P equals N by P. Okay, if and only if condition. So here clearly P by 3 equals 1 by 3. P bar 3 equals 1 bar 3. So evaluation of P bar 3 equals, P by 3 equals, P by 3 equals 1 by 3. Then what is 1 by 3? 1 by 3 is 1. Evaluation of, come on, what is 1 by P? 1 by P is strictly 1 itself. Clear? Okay. 1 by 3 is 1. So this P by, okay. So it is 1 by 3 equals 1 means P by 3 equals 1. That implies P by 3 equals 1. Enough? Okay. Now, P congruence to 1 mod 4. Consider the second argument. P congruence to 1 mod 4. P congruence to 1 mod 4 means, what is P minus 1 by 2? Clearly, P minus 1 by 2 is even. Okay? P minus 1 by 2 is even. By P congruence to 1 by 4 means P minus 1 is a multiple of 4. Agreed? That means P minus 1 equals 4 lambda implies P minus 1 by 2 equals 2 lambda. Hence it is even. So P minus 1 by 2 is even. P minus 1 by 2 is even means, so what is minus 1 power P minus 1 by 2? Minus 1 power P minus 1 by 2 means minus 1 power even. So it is 1. So when P is congruence to 1 mod 12, P by 3 is 1 and minus 1 power P minus 1 by 2 is 1. So from here, what is 3 by P? 3 by P equals 1 into 1. So 3 by P equals 1 means 3 is a quadratic residue mod P. 3 RP. Clear? Okay. Now come to the second case. When P congruence to 5 mod 12. Come to the second case. P congruence to 5 mod 12. P congruence to 5 mod 12 means P congruence to 5 mod 3 and P congruence to 5 mod 4. But P congruence to 5 mod 3. So in mod 3, what is 5? In mod 3, 5 is 2. Clear? If you divide 5 by 3, remainder is 2. So in mod 3, 5 is 2. So P congruence to 5 mod 3 can be rewritten as P congruence to 2 mod 3. Clear? P congruence to 2 mod 3 because in mod 3, 5 is 2. So again, M congruence to N mod P means M by P is N by P. So that implies P by 3 equals 2 by 3. So evaluation of 2 by P. What is evaluation of 2 by P? Evaluation of 2 by P is minus 1 power P square minus 1 by 8. What is P square? 3 square minus 1 by 8. 9 minus 1 by 8. So it is minus 1 means P by 3 equals minus 1. P by 3 equals minus 1. Okay? P by 3 is minus 1. Now, when P congruence to 5 mod 4, second case. P congruence to 5 mod 4. So listen, with respect to mod 4, 5 is 1. So clearly P congruence to 1 mod 4. Sure? P congruence to 1 mod 4. P congruence to 1 mod 4, then we see that clearly P minus 1 by 2 is even. Okay? P congruence to 1 mod 4, P minus 1 by 2 is even. So what is minus 1 power P minus 1 by 2? Minus 1 power P minus 1 by 2 is 1. Clear? Therefore, when P congruence to 5 mod 12, then 3 by P equals P by 3 minus 1 minus P minus 1 power P minus 1 by 2 is 1 is minus 1. So here 3 R bar P. It's a quadratic non-residue mod P. Clear? Yes. Come to the next case. When P congruence to, what is the next one? When P congruence to 7 mod 12. What happens here? P congruence to 7 mod 12. When P congruence to 7 mod 12, then clearly P congruence to 7 mod 3 and P congruence to 7 mod 4. Sure? Yes. In mod 3, what is 7? 7 is 1. Sure? Okay. So when P congruence to 7 mod 3, P congruence to 7 mod 3 means P congruence to 1 mod 3. Clear? P congruence to 1 mod 3 means P by 3 equals 1 by 3. What is 1 by 3? 1 by 3 is 1. Sure? Yes, evaluation of 1 by P. So P by 3 equals 1 by 3 equals 1. So means P by 3. So yes, P by 3 equals 1. Okay, P by 3 equals 1. When P congruence to 7 mod 4, P congruence to 7 mod 4. So in mod 4, what is 7? It is 3. So that means P congruence to 3 mod 4. P congruence to 3 mod 4. P congruence to 3 mod 4 means clearly we know that P minus 1 by 2 is odd. Sure? When P congruence to 1 mod 4, P minus 1 by 2 is even. When P congruence to 3 mod 4, P minus 1 by 2 is odd. How? If, suppose P is 19. 19. Surely 19 congruence to 3 mod 4. Okay? 19 congruence to 3 mod 4. 19 minus 3, 16. Okay. So, when P equals 90, what is P minus 1 by 2? 19 minus 1, 18. 18 by 2 is 9. So, it is odd. So, when P congruence to 3 mod 4, surely P minus 1 by 2 is odd. So, when since P minus 1 by 2 is odd, so what is minus 1 power P minus 1 by 2? That is minus 1. So, what you get? Then, again 3 by P equals P bar 3. What is P bar 3? 1 into minus 1 is minus 1. So, it is again 3 is quadratic non-residue mod P. Clear? And come to the last case. When P congruence to 11 mod 12. What about here? P congruence to 11 mod 12. So, 11 mod 12 means P congruence to 11 mod 3 or P congruence to 11 and P congruence to 11 mod 4. Clear? Or as P congruence to 11 mod 12 means P congruence to minus 1 mod 12 also. So, it is P by 12 equals minus 1 by 12, then that evaluation. For more convenience, it is P congruence to 11 mod 3 and P congruence to 11 mod 4. In 11, now consider P congruence to 11 mod 3. P congruence to 11 mod 3. In mod 3, what is 11? 11 is 2. So it is P congruence to 2 mod 3. If you divide 11 by 3, remainder is 2. So again, that means M by P equals N by P means so it is P by 3 equals 2 by 3. Evaluation of 2 by 3. What is evaluation of 2 by P? Minus 1 power P square minus 1 means 3 square minus 1 by 8 equals minus 1. P by 3 is minus 1. Clear? When P congruence to 11 mod 4. So in mod 4, what is 11? 11 is 3. 2 into 4 8, remainder 3. So it is 3 mod 4. Okay. Now we already see that when P congruence to 3 mod 4, P minus 1 by 2 is odd. In previous case, we already see that P minus 1 by 2 is odd when P congruence to 3 mod 4. So minus 1 power P minus 1 by 2 is minus 1 power odd means minus 1. Thus, therefore, 3 by P equals P by 3 minus 1 into minus 1 power P minus 1 by 2 equals 1. So 3 is a quadratic residue mod P. So here 1 and 11 are quadratic residues mod P. 5 and 7 are quadratic non-residue mod P. 1 and 11 are quadratic residues means, listen, 1 and 11 are quadratic residues. 1 and 11 are quadratic residue mod P. What is 11 actually? 11 congruence to, P congruence to 11 mod 12 means, listen, P congruence to 11 mod 12 means, P congruence to 11 means when in mod 12 11 is minus 1, so it is P congruence to minus 1 mod 12. So the P also we know that when P congruence to 1 mod 12, it is 3 is quadratic residue mod P. When P congruence to 11 mod 12, instead of P congruence to minus 1 mod 12, 3 is also quadratic residue mod P. So concluding, 3 is quadratic residue mod P if P congruence to plus or minus 1 mod 12. Okay, so 3 is quadratic residue mod P if P congruence to plus or minus 1 mod 12. Clear? Now 3 is quadratic non-residue mode P for the primes 5 and 7. Clear? For the primes 5 and 7 means P congruence to 5 mod 12. So it is when P congruence to 5 mod 12, 3 is quadratic non-residue. 5 mod 12 means 5 mod 12. So in mod 12, what is 5 mod 12? Come on. When P congruence to 5 mod 12, it is quadratic non-residue, as well as P congruence to 7 mod 12, it is also quadratic non-residue. So 7 mod 12 means it is P congruence to minus 5 mod 12. Okay. P congruence to 5 mod 12, there is 3 R bar P, and P congruence to 7 mod 12, it is 3 R bar P. So P congruence to 7 mod 12 can be rewritten as P congruence to minus 5 mod 12. So when P congruence to minus 5 mod 12, it is also 3 R bar P. So we have collectively P congruence to plus or minus 5 mod. When P congruence to plus or minus 5 mod 12, then 3 is quadratic non-residue mod 12. Clear? Okay. So this is our conclusion. Agreed? Clear? So in the same way, you can draw another one. So consider another problem. If 5 is a quadratic residue of an order prime, then prove that if P is plus or minus P congruence to plus or minus 1 mod 10, and a non-residue if P congruence to plus or minus 3 mod 10. Okay. Clear? So let us take as an exercise. Then the procedures are same like this one. Agree? Okay. Now we consider. So here we studied about legendary symbol. What is legendary symbol? Legendary symbol is n by p. So where p be an order prime, and when n is in congruence to 0 mod p, then the legendary symbol is n by p is 1 if n rp, and come on, n by p is 1 when rp, and yes, n by p is minus 1 if n r bar p. That is legendary symbol. Also we say that from in legendary symbol, what is 1 by p? 1 by p is always 1. Clear? 1 by p is 1. So legendary symbol, in legendary symbol, when n is incongruence to 0 mod p for any odd prime p, that is legendary symbol. For any odd prime p, then n bar p equals 1 or minus 1 when it is quadratic residue or non-residue mod p, and when or with a n incongruence to 0 mod p. Here we consider only the odd primes p. Instead of this odd prime p, so for any composite number, suppose p is not a prime, it is a composite number. So how to evaluate this n by p? So this evaluation is done by using another symbol which is known as Jacobian symbol. Jacobian symbol is nothing but an extension of legendary symbol. The legendary symbol is that not only when p is an any order prime, but for evaluating this n by p when p is not a prime, means it's composite or the product of primes. Then here we use instead of legendary symbol, here we use Jacobi symbol. So we conclude that Jacobi symbol is nothing but an extension of this legendary symbol. How it is defined? So for if p be any odd positive integer, not a prime, it is odd positive, p be an odd positive integer with a prime factorization, p equals product I ranges from 1 to r pi power ai. This is the prime factorization of this odd positive integer p. Then the Jacobian symbol n bar p or n by p is defined as, for all integer by the equation n by p equals product I ranges from 1 to r n bar pi all power a. N bar pi all power a. Where n bar pi be, what is n bar pi? N bar pi means it is legendary symbol. That is a well-known function. It is legendary symbol. What is legendary symbol? N by p is 1 when n rp and minus 1 when n r bar p. So here n by pi, n bar pi, or n by pi, whatever may be, it is 1 plus or minus 1 according as it is. N is quadratic residue or non-residue with the mod pi. Okay. So when p is an odd positive integer, and if p is the product of primes, p is product I ranges from 1 to r, pi power I, then Jacobian symbol is defined in terms of Legendre symbol, that is n by p is product I ranges from 1 to r, n by pi or power ai, where n by pi is the Legendre symbol. Okay, so in Legendre symbol we know that 1 by p equals 1. Here we define n by 1 equals 1. Here we define n by 1 equals 1. 1 by p in Legendre symbol 1 by p is 1, and in Jacobian symbol we define n by 1 equals 1. Okay. Then the possible values of n by p. Here, since pbn, here pi's are order primes. Pbn order positive integer, pi's are order primes. Here, then the possible values of n by p are plus or minus 1 or 0. Okay, plus or minus 1 or 0. Now, when n by p is 0, n by p equals 0, if and only if GCD of n by p is strictly greater than 1. So, Legendre symbol is defined or defined when n is in concurrence to 0 mod p for every order prime p, and the n by p equals when n concurrence to 0 mod p. What is Legendre symbol? N by p equals 0. Okay, in Legendre symbol, when p divides the n, what is n by p? N by p equals 0. Means when n concurrence to 0 mod p, n by p equals 0. Here n by p equals in Jacobian symbol n by p equals 0 if and only if GCD of n and p are greater than 1. Means if they have any common factor, then n by p should be 0. Okay. Now consider the congruence relation. X square congruence to n mod p. Consider the congruence relation. X square congruence to n mod p has a solution. If this x square congruence to n mod p has a solution, means when x equals 1 and x equals minus 1. So x square congruence to n mod p has a solution, then what is n by pi? N by pi equals 1. Okay, then n by pi equals 1 for each prime. For each prime pi, hence we have n by p is also 1. If x square congruence to n mod p has a solution, then n by pi equals 1. So therefore n by p equals 1. Reverse inclusion need not be true. Why? Because n by p equals 1 when n by p equals 1 if an even number of factors presents in where in this n by p equals product I ranges from 1 to r, n by pi all power a. Okay. Now this is the Jacobian symbol, Jacobi symbol. Now let us